Hi guys, so welcoming you back in the new video of the same topic, which is propositional logic and hardware. So we have already covered the starting thing like the connectives, which are also called operators, and the basic gates, and how can we find the conclusion with the help of algebraic method and with the help of truth table. Even we discussed about the universal gate and the basic gates, like the basic gates are AND, OR and NOT, and the universal gates are NAND and NOR. So in the last video, we covered the NAND gate, which is under the category of universal gates. And today we are going to cover NOR gates. So let us start our session. Now the first thing is NOR gate. The symbolic diagram for the NOR gate is required. So first, as you know, these all are interrelated videos. So if you don't know how can we draw the NOT gate and how can we draw OR gate, then it's not possible for you to understand this NOR gate properly. So I'll suggest you to please check the previous videos. I have created a proper video for the explanation of the basic gates, because these two, NOT and OR, they both are under the category of basic gates, right? So let us start. First, I'll draw the OR gate. So in this way, you can draw the OR gate, right? And then, NOT gate. So this is your NOR gate, fine. And now if you are joining both, so this one is OR gate and this is NOR gate. And when you are joining both of them, this is the input and the output. So this is actually the symbolic diagram for the NOR gate. But if you know like how we compress this diagram in NAND gate also. So in NAND gate also we actually join this OR gate along with the NOT gate. So how can we change it? So in that case you will again draw it properly, the OR gate, and then you will draw a circle here just to denote OR. So this is NOT plus OR and this will become NOR gate. Okay, so this is the symbolic diagram for the NOR gate. You can draw it in this way also, which is more popular, right? So I hope you are clear how can we draw the symbolic diagram for the NOR gate. Well, the same thing, you please check it properly here. Here we have NOR to NOR logic or operation. So you know three operations are there, AND, OR and NOT. So we are starting from which operation? This is the first operation, OR gate. Okay, so if you will remember the previous thing, so OR gate is with the help of plus sign we are denoting, right? So if two what inputs are there, so A plus B is the OR operation. So if it is possible for you to find this one as an output only with the help of NOR gate, that means you will be able to fulfill this condition OR operation, right? So please check it properly. This is the symbolic diagram and the algebraic proof is given afterwards. Okay, so we have A plus B is equal to A NOR B, and in between also you have a NOR and then A NOR B. Okay, so please check it properly. You have a NOR gate here. I told you already this one, and then you have a A here, then you have a B here. These two are the inputs, right? Inputs. And then these two inputs we are giving into the NOR gate, and the output is A plus B, which is the OR operation. What is this? NOR is actually NOT plus OR. So OR operation is what? This one is OR operation, and NOT operation will give a bar onto the OR operation. So this will become A plus B bar. So here also we are getting the same A plus B bar. Okay, so now this is a single input. This is a type of expression but is a single input, and when again you will put it into the NOR gate, it will give you A plus B, and bar is already there, right? So it will give you A plus B, bar is already there, and one more bar. So double bar you can just remove it because there is no use of double bar. So that bars will be removed and you will get the final operation, which is the OR operation, right? So just you have to remember this one, because if any requirement is there in which you have to use only NOR gate and they are asking for OR operation, so this is the way we are going to draw it, the circuit diagram. Now the second operation is, this is the B part, the second operation, which is AND operation. So AND operation, you remember, and operation we are denoting with the help of dot. So if inputs are to A and B, so A and B, right? This is AND operation. So please check it with the help of NOR to NOR logic. Please check it. We have the single input here. As you know, NOR is also the same thing, OR gate and not of it. So this will give bar to the input. So we are getting A bar. Input was A and the output will be bar over there. Then input was B. So output will be B bar, A bar. And when these two will go inside it, this will give you A bar, B bar, and in between dot will come and upside one more bar. Okay, so when you will, simplify it, you will get A dot B, right? A dot B. And A dot B is which operation? This is AND operation. So if you want to apply the AND operation, this is the symbolic diagram. Okay. Then the final one is the NOT operation. So please check the NOT operation properly. Just the input is there. You have the input A, and when it is going inside the NOR gate, it is giving you the bar. Okay. So NOT of A is equal to A NOR A. Just you have to put a NOR symbol here. Okay. NOR gate in between. So well, these three are there. Now a simple diagram is there. The way to draw a circuit diagram only with the help of NOR gate. Can you see design rule? If you know the same type of questions we did in the previous session also, remember, in that case here we replaced those NOR to NAND. So they were saying to draw a circuit diagram, and that was also for 2 level, because in your portion it is only for the 2 level, which is quite easy. And similar also in case of NAND gate also, even in NOR gate also. Okay, but yeah, you should be clear how to draw NOR gate, and if they are asking for NAND gate, then you should be clear how to draw NAND gate. So we have tried a simplified product of sum forms of the expression. Okay, sum, product of sum. Okay, and then product of sum, then draw a circuit diagram. And this also they are just asking you to draw this circuit diagram with the help of the basic gates and or and not, right? And or and not also you can write it down, because these three are under the category of basic gates. And finally you will substitute the NOR gate instead, using the OR and NOT gate. You will just replace and or and NOT gate by the NOR gate. Okay, so this is almost same only, just we should be clear with the diagram. So one of the example, the solved one I have taken here, x plus y, y plus z, z plus x. So this is which form? Product of sum form. Product of sum, right? So product of sum is what? You will start from here, sum. So here you have sum, right? And the product of this sum. So you can see this is the product of the sum. So this is called product of sum expression. Okay, now we will go for the circuit diagram. So here if you will simplify this, and if you remember the plus, you will replace with what? Or. So this is x or y, and then you will put, you have a dot here which you will replace with and, right? And then we have y or z, and then you will put and then you will write z or x, right? So this is the way. And yeah, now please check it, x or y. So here you have a OR gate and the inputs are x and y. So right, now we have the OR gate again. So here you will get x plus y, here you will get y plus z, and because the inputs are y and z, and here you will get z plus x or x plus z. Fine. When these all are connected with AND operation, and you are getting finally this one. Perfect. What they are saying, then you have to just change OR with OR and not, if not is not there, because we don't have any bar here in this expression. So but in case if not is also there, then not also you will replace with NOR gate only. So now just you don't have to use your SHNE knowledge, or nothing is required. Just we have to replace the OR gate with a NOR gate, right? So we have a OR here, NOR, and this AND also with NOR, and the final expression is exactly the same. The final output is exactly the same, right? So I hope you are clear with this. Now we can go with NOR to NOR form. Actually it was given in the previous example only, so we are already done with this one. Now we can go with one more example. So let me write one question here. So I am writing here, it is suppose A bar plus B bar plus C bar, and here you have A plus B bar plus C and then you have A plus B plus C bar. Okay, and obviously NOR to NOR logic gate. So yeah, let us start with this one. So first you please write it down. It is A bar. So what you will write? You will write not of A, right? And then plus sign is there. So plus sign is for what? It is for OR, right? Plus sign is for OR. So you will write OR here. Then again not of B. Then you will write OR here. Then you will write not of C, and the whole thing you will put it in bracket, and this dot you will change it with AND gate, and again this one. So you will write A or not of B, okay, and then or you have C, and this whole thing you put it in bracket, and then again you will write one AND here, and this time you have A and then what? Or B and then or not of C, right? This is the expanded form. So it's good to write it down because sometimes they are just, asking you to go with these expanded forms only. So let us go with the diagram. So directly I'm going with the diagram. You can just check it properly here again. The expression, it is what? The expression is A bar plus B bar plus C bar. Okay, A bar plus B bar plus C bar. So A bar. So A bar, for that you will use a NOR gate here, right? So I'm just drawing a small A bar because this is a single, input is there. So this is like that only. The single input we used to show it like that, okay? And then this is A. Okay, so well, this is going inside. Then you have A bar, B bar and C bar. So draw it for the same thing for B also, which will give you, B bar, and draw it one more time. And this will give you C bar. Okay, C. So perfect only. This is the input. Well, just a minute. I'll just draw it properly. Yes, perfect. Okay, so this is done only, and all the three I have to just small the space, and they are connecting how? They are just using one AND gate in between. So yeah, so that AND though is not there, that you have to replace with NOR gate, right? So I'm not drawing a NOR gate here, and this will give you A bar plus B bar plus C bar, and this will give you whole bar. Okay, the same thing. Now I'll check the second expression. The second expression is A plus B bar plus C. Okay, so again A you have to give. So this is the normal input only. This is A, and the second is B bar. So again for B bar you will draw this gate again. Okay, and the single input with like this. Okay, this will give you B bar and then normal C. So C to like that only you give, and then again you will connect it with the help of which gate? NOR gate, because everything, all the gates you have to replace with NOR only. Okay, so this is I am writing here NOR, here also I am writing NOR, and this time it will give you A plus B bar plus C and the whole bar. Now the third expression, let us check the third expression. So the third expression is A plus B plus C bar, right? A plus B plus C bar. So this is A again. So A to direct you give, it is A, and then B also direct you give B, and then C bar. So draw it properly, and then you give C bar. Okay, this is C and C bar. So again you just connect them together. So these all again. So here I am again drawing one NOR gate, okay, and this NOR will give you A plus B plus C bar and whole bar, right? So all the expression is done only, and they all are connecting again with the AND gate. So that also we have to replace with NOR only. So just draw one more time NOR gate. Okay, NOR, and you are done. Okay, so this is F, A, B and C, or you can replace it with the complete expression. Okay, so well, here we finished NOR gate also. So I hope you are clear with everything, but still if you have any doubt, please drop a message in the comment. I'll sort it out. Okay, so if you are clear with everything, please don't forget to like, subscribe and to share it with your friends. Thank you.